Hi, welcome back. Alright, so today we're going to talk about multiplicity. And multiplicity, what is multiplicity? Multiplicity tells us how many times a root occurs in a polynomial. It tells how many times a root occurs. So when we graph a polynomial and it crosses the x-axis, those points are all our roots. And sometimes they can happen once, sometimes they can happen twice, 3 times, more than that. And the multiplicity will help us determine or helps us identify how many times a root actually occurs. So the best way to determine the multiplicity of a root is to actually look at the graph of the polynomial. So I just have a very random polynomial graphed here. I don't even know which polynomial it is, but you can see that this polynomial hits the x-axis in 3 spots. And each of these 3 spots shows us a different way that we might see a graph and a root occur when it's graphed. So on the left here, where we have the graph just goes straight through the x-axis and hits it one time straight through, up and down. If your graph looks like this, at this point, we're going to have a multiplicity equal to 1. Okay, so when it just goes straight through with nothing fancy, that's a multiplicity equal to 1. Okay, then we have the part of the graph that goes up, touches the x-axis, and comes right back down. So if that happens, where it doesn't actually cross over the x-axis, it just touches it and goes back the way it came from, we're going to say that's an even multiplicity. So numbers that happen at this point, we could say might happen twice or 4 times or 6 times, depending on the degree of the polynomial we're looking at. And then finally, we have the graph goes up, hits the x-axis, slides along the x-axis before continuing along its way. Those are going to be our odd multiplicities, and those have to be greater than 1, since we already know that if it was a multiplicity of 1, it would just go straight through with no slide. So these are the 3 types of points that you'll see on the graph to help determine if it's an even multiplicity, an odd multiplicity, or just a multiplicity of 1. So we're going to look at an example to see specifically how we can use this information to determine the multiplicity, and then use synthetic division to confirm what we think is true. So I have an example here. It's x to the 4th minus 3x cubed minus 18x squared plus 32x plus 96. So the first thing you want to do is you want to graph your polynomial. Use your graphing calculator. There's apps, I think, available, but you want to graph your polynomial. You can see from just the graph here that we have 3 points where this graph hits the x-axis. We have a point at -3, we have a point at -2, and we have a point at 4. So at -3 and -2, the graph goes straight through each point and across to the other side. So it goes from positive y down to negative y, and then negative y up to positive y. So there we can expect a multiplicity of 1, meaning that each of those roots only happen 1 time. At the 4, at x equals 4, you can see the graph comes down, touches at 4, and then goes back up. So that, to us, if you remember, that's an even multiplicity. So we would expect that to happen 2, 4, 6, etc. number of times. Now, the way we actually figure out how many times is we need to look at our degree. This is a 4th degree polynomial, and we know that because we have an x to the 4th as our highest power here, which means we have to have 4 roots. So if we're expecting 1 root to happen at -3, 1 root to happen at -2, then we are expecting 2 roots to happen at 4. And using synthetic division, we can very easily check this or confirm this. So if you need to refresher on synthetic division, there is another video up on how to do synthetic division. I'm not going to spend a whole lot of time in this section explaining the process, but feel free to pause this, go back and look at those videos, and then come back. So with this, so we're going to start, let's start with the -3. So my -3 is going to go on the outside, and then the coefficients of my polynomial, so 1, -3, -18, 32, 96, and now I'm going to use synthetic division. Remember, -3 is a root if our remainder, our last number when we do synthetic division, ends up being 0. So let's go through the process. 18, 0, 0, 32, -96, and 0. So we have 0 as the last number here, so we can definitely conclude that x equals -3 is a root. Okay, now let's just say we thought that -3 may occur again. So we can definitely, building off of the numbers we have here, do -3 again. This would help either confirm or deny whether -3 has multiplicity more than once. So if we do synthetic division here, we can see that we don't get a 0 in our last spot here. Okay, so we can see that we get a -22 here, which is not a 0, which tells us that even though -3 worked once, it's not going to work a second time. So we're going to have x equals -3. The multiplicity here is just going to be 1. So once we've determined that, let me just erase the -3. We can move on to our next root. So the next root we have is -2. So we're going to do synthetic division with -2. Bring this down. This is -8. We get 16, 16, and -32 gives us a 0. So we can see that x equals -2 works as well. And from the drawing alone, we can see that we have a multiplicity of 1. Okay. Finally, we have our 2, that is, I'm sorry, not a 2, our 4 as a root. So we're going to check the 4. 1, 4, -4, -16. 4 works definitely one time, and we're going to check it again. So we do synthetic division one last time, and we can see that 4 works a second time. So now we have 4 as a multiplicity of 2. So -3 happens one time, -2 happens one time, and 4 happens twice, which altogether gives us our 4 roots that we need for a 4th degree polynomial. So let's take a look at one more example. Okay, here we have x to the 4th minus 5x cubed plus 6x squared plus 4x minus 8. So again, we have a 4th degree polynomial, so we are expecting 4 roots. If I graph this, I get something that looks like the picture over here off to the right, and I can see that I have a root at this point at -1, and also a root at 2. Now at -1, my graph goes straight through from top to bottom. So remembering what we talked about before, we would expect that to be a multiplicity of 1. So we're going to say x equals -1. We're expecting a multiplicity of 1. Now at 2, the graph goes to 2, but here's that slide we were talking about. Slides along the x-axis before continuing it up. So at x equals 2, we know that has to be an odd multiplicity. And since we know we need 4 roots altogether, the only multiplicity we can have is a multiplicity of 3. So now let's use synthetic division to confirm all of this. I'm going to start with my -1 and my coefficients 1, -5, 6, 4, negative 8. In doing so, let's see, I get negative 1, negative 6, 6, 0, 0, 4. Oh, wait a minute. Let me back up here. Negative 1, negative 6, 6, this is 12. Negative 12, negative 8, 8, and 0. There we go. All right, so we know that negative 1 works. Now let's check 2. And remember, since we're expecting 2 having a multiplicity of 3, we're going to do the synthetic division 3 times using 2. So bring down the 1. We have 2, negative 4, negative 8, 4, 8. So works 1 time. Let's try it a second time. Works a second time. So let's try it the third time. And it works the third time. So our final answers, x equals 1 with a multiplicity, x equals negative 1 with a multiplicity of 1, and x equals 2 with a multiplicity of 3 are the roots of our polynomial. So hopefully that is a review for you on multiplicity, what it is, how to use a graph to help determine the multiplicity, and then how we use and apply synthetic division to confirm and check what we believe the multiplicity is. So feel free to watch the video again. Again, if you need help with synthetic division, look for another video in the video section of the website for synthetic division, because you will be using a lot of that to confirm multiplicity and also for solving polynomial equations as well. So hopefully you found this helpful, and I will see you again soon. Bye-bye.